Welcome to Math TV with Professor V, and happy Monday. It is July 17th, 2023. Here's your integral of the day. Definite integral from 0 to pi over 3, sine of x times natural log of cosine x dx. Little hint, you'll need more than one integration technique. So pause it, give it a go on your own if you'd like. I'm going to jump right in. First things first, we're going to need to do a u substitution. How do I know that? I see a composition of functions, right? I have cosine of x sitting inside ln of x. So I have ln of cosine of x. And then because I know my derivatives, I know, derivative of cosine x. It's negative sine x, but that's good enough. We can do a u sub. But I'm just kind of thinking ahead, and I can tell that I'm still going to be left with the ln and need to do integration by parts after. So instead of using the variable u for my substitution, I'm going to use t because I want to save it for when I do by parts. So I'm going to let t equal cosine of x, and then dt will be negative sine x dx. And don't worry about the negative. We can always add that into the integral. The most important part is that we have that sine x dx right here. So then if you want to get it all matchy-matchy, negative dt is sine x dx. And then watch how we're going to rewrite our integral. Now we just have ln of t dt, and then I always recommend you put the minus sign outside, okay? Let's also change our limits of integration while we're at it. So t of 0, I'm going to plug in 0 for x. So cosine of 0 is 1. And then t of pi over 3, that's cosine of pi over 3, which is a half. All right, so new lower limits 1, new upper limits 1/2. Now let's just talk about how I made that substitution first so seamlessly. In case you were thinking about a couple other options, here's a bad idea. I would say like the most common mistake I see students do is they attach the ln in the substitution. That's too much because remember we have to do this thing called the chain rule, yes? So the derivative of ln something would be 1 over the something times the derivative of the something, okay? And I don't have all of this in my integral. Primarily, I don't have an extra 1 over cosine x. Do you see that? So that's why this is a bad choice. And sometimes you have to write the bad choice down, go through the steps, and then see why it doesn't work out so that next time you learn and you don't pick the bad choice, okay? But it's fine. It just takes practice. Not everyone, most people don't come out of the womb doing integrals. You have to practice to become a professional. All right, now let's knock out what's left. For sure, let's get rid of the negative by flipping the limits of integration. Okay, so now we have positive 1/2 to 1 natural log of t dt. And then some students, honestly, because they know that anytime you have integral of natural log of x, they want to just memorize the pattern instead of going through the whole integration by parts. It's up to you. I don't memorize that much. I memorize as little as possible. So I just, it takes a minute. So u is ln of t, dv is dt, du is 1 over t dt, and then v is just t. Okay, so then we're going to have uv, that's t ln of t evaluated from 1/2 to 1 minus integral v du, and that will be 1 over t times t dt, again from 1/2 to 1. All right, then we're left with t ln of t evaluated from 1/2 to 1 minus, oh look, this is so lovely, 1 over t and t cancels. So then we just have integral 1/2 to 1 dt. There's a little 1 sitting there. We don't need to write it. So t ln of t minus antiderivative of 1 is just going to be t. And then now I can evaluate all of this from 1/2 to 1. And then let's see. 1 times ln of 1 minus 1 minus lower limit 1/2 ln of a half minus a half. Good. And then let's see. ln of 1 is 0, so that's gone. So I have here negative 1 minus 1/2 ln of 1/2, and then plus 1/2 when that minus distributes. These are like terms, are they not? Yes, they are, Professor V. Oh, good. So we have minus 1/2 ln of 1/2 minus 1/2. And no, we're not leaving it like this. Are you ready? Log property time. This negative, we can move, make it an exponent on the 1/2. What's 1/2 to the negative first? Anytime you raise a fraction to the negative power, you take the reciprocal, and then it's raised to the first, so that's just 2. Okay, so then this means this is now positive 1/2 ln of 2 minus 1/2. And that's how you'll find the answer in the back of the book. Plus, general rule, it's more aesthetically pleasing. If you can get rid of a negative in the front of your answer, you do it, okay? So I hope you enjoyed the integral of the day. And yes, back to my little rant I was saying earlier, I always will tell my students when they'll tell me sometimes like, oh, when I watch you do problems, it looks so easy. And then I have a hard time when I do it myself. And you know, that's very normal. No one comes out of the womb doing calculus or solving integrals. You got to practice. How much practice? That depends on you and a lot of factors. Life's not fair. We all have a different set of circumstances and abilities. But at this level, with enough practice, determination, you can get it. You can become a master of these integrals. So I hope that inspires you for the day. Attack whatever you're attacking with enthusiasm. And then give the video a thumbs up. Subscribe if you haven't already. You can also catch me on Instagram at TikTok at MathTV with Professor V. Have a lovely, lovely day, you guys. Bye.